Alright, moving on now to Integral Calculus Part 2. It's an introduction to antidifferentiation or integrating. And here we get the integral of 1 over x dx. And the integral of 1 over x dx is log x to the e, x to the base e plus c. And that's because the derivative of that, if you remember back, was 1 over x. So the integral of 1 over x is going to be log x to the base e. Remembering that in log expressions, if I just change to green here for a moment, that x there can't be negative. Okay, it can only be positive. So I want to introduce you to absolute value signs here. They used to be in the course a lot more, but actually, thankfully, to be honest, they no longer are. They're a bit of a pain to teach, but anyway. So those two signs there and there, I've just pointed to with arrows, are called absolute value signs. What they mean is they mean that the value of x is always greater than 0. Okay, if it was a negative value, it would be turned to a positive. Okay, so it's absolute value. So it's the value regardless of sign, positive or negative. That's what it means, absolute value. So if you don't use those signs, it means that you've got to always put this little condition here over to the right, where x is greater than 0. So instead of having to write that every time, because we know that we can't have x that is negative in a log expression there, we put the x around absolute value signs, which means x is always greater than 0, I suppose. It's another way of saying it. So let's leave it at that. So now, of course, 1 over x can be also expressed as x to the power of negative 1. And you can see there that I've expressed that there like that. So they're actually the same thing. 1 over x and x to the power of negative 1. Hence, they've got the same result here. Log x to the base e plus c. Log x to the base e plus c. Remember to put those absolute value signs in each time. Alright, so what does that mean? Now, here I've started with a pretty tricky question to start with, because I really want you to practice here in doing the following. And this is hard to see, guys. So what I'm going to do is just show you that 4 over 7x can also be written as 4 over 7 times 1 over x. See if you can look at that and equate those two things. It's very, very important that you can do that split up there, because it makes this question more straightforward. Okay, so with that in mind, we can actually break up this to the integral of, if we just go 4 on 7 times 1 on x dx. And further than that, we know that 4 on 7 then can be taken out the front. We saw that rule before that said something like, if you've got integral of 5x squared, it's the same as 5 times the integral of x squared. So that sort of thing there. So we can do that little take out the front there. So that means we're going to get, forgetting my equal signs, we're going to get the integral, or 4 on 7, the integral of 1 over x dx, okay, which equals 4 on 7, and the integral of 1 over x is log x to the base e, absolute value, plus c. So there's our answer. An extension of what we've just looked at is this rule here, the integral of ax plus b to the power of negative 1. That could also be written as the integral of 1 over ax plus b, of course. Same thing. And that equals 1 over a, log ax plus b to the base e. And once again, we've got a that in absolute value, which means it can't be negative, plus c. So let's try it out. Just copy it over to the next slide so we can have a look at it when we do this next problem. So here it is. Okay, So what we've got here is 5 over 2x plus 3 dx, the integral. Okay. So let's start off here by separating this out. And what I want to show you again is that 5 over 2x plus 3 equals 5 times 1 over 2x plus 3. So what I can do here is take that 5 out the front. So it's 5 integral of 1 over 2x plus 3 dx. Okay, so that could also be written as 5 integral 2x plus 3 to the power of negative 1 dx. And here's where we can spin in our rule. Here it is. Okay, so let's apply it. I might go crossways here. So it's 1 over a. Well, actually, we'll go back a step. We've got the 5 already sitting out the front, so that just sits there. Okay, and then we've got this rule here, which says it's 1 over a. So let's start with 1 over a. So times a is the coefficient of x, which is 2. There it is there. Okay. Log base e, the bracket as it stands, so it's 2x plus 3, absolute value plus c. Now if we tidy that up, we're going to get, I'll squeeze it in here, 5 times a half is 5 on 2, log base e, 2x plus 3, and let's get rid of 2 for a sec, more room, and sorry, should be an absolute value, plus c. There we go. Separate out the 5 first up. Remember that it can be broken up like that. That means the 5 pops out the front, and then we apply the rule that we've got there. All these rules, by the way, are on our information sheet. Let's look at this one. We've got the integral of 6x plus 5 over x squared. Now we can break that up into the integral of 6x over x squared plus the integral of 5 over x squared equals, our dx's, a bit neater there. There we go. Now 6x over x squared, look at that in isolation, guys. The x's cancel, and that can become the integral of 6 over x, okay, plus integral of 5 over x squared, and put our dx's in. This is where we can put our 6 and 5 out the front. So this becomes 6 integral 1 over x. Why? Because 6 over x is the same as 6 times 1 over x. Dx plus 5 pops out the front, integral 1 over x squared. And I'm actually going to change that to x to the minus 2. Okay, so we've got 2 integrals here. Now, remember the integral of 1 over x is log x to the base e. Okay, the integral, so we've got 5 here, and the integral of x to the minus 2, we raise the index by 1 over the same index. Okay, that's our general rule. You'll hear me say it over and over again, raise the index by 1 over the same index. So that equals, and we've got plus c, sorry, I should put that in, equals 6 log x to the base e. Now 5 over negative 1 is negative 5. X to the power of negative 1 is over x plus c. So just, I went through that a bit quickly, so just make sure you can see that that and that are the same thing. Okay, negative 5 over negative 1 is negative 5. X to the power of 1 is, we put the x to the power of 1 on the bottom. Okay, so there is our answer. Next question, find the equation of the curve g of x, given that g dash of x equals 3 root x plus 2, and the curve passes through 1, 2. Alright, this is a classic question here. Now, cut through all the words here. We've got to find the original equation. We're given the derivative, and we've got to find the original equation. And we're given a point. Okay, 1 and 2. Alright, So what we've been doing is actually finding original equations. Okay, so if we've got g dash of x equals 3 root x plus 2, to find g of x, to find g of x, we get the antiderivative of 3 root x plus 2. Because we've got the derivative, to get the original we get the antiderivative. Okay, so that's going to be and dx. That's going to be the integral of 3 root x plus the integral of 2 dx and dx. Make that a bit neater there with the addition sign. So I'll split those up. So go to the next slide. So that's going to equal 3 integral of x to the half plus integral of 2 dx. There's a dx in there as well. Equals, okay, so we've got 3 integral of a half. So we've got, integral of x to the half. So we add 1, so we get to the index 3 on 2 over the same index, plus integral of 2 is 2x plus c. Okay, this one continues on from part 2, so we're into part 3 here. So how are we going to deal with this? Okay, so remember, if I digress over here, if we're going 3x to the power of 3 on 2 divided, x to the power of 3 on 2 divided by 3 on 2, we invert and multiply, it's actually by 2 on 3. So that means those 3's will cancel, and effectively what we've got here is the 2 goes out the front. What I've got in the blue box actually gives me 2x to the power of 3 on 2. So just please pause this if you don't see it. What I've got in the blue box equals what's in the blue box here. They're the same thing. Plus 2x plus c. Okay, so that's my equation there for g of x. Alright, so my g dash of x was this. My g of x, I'll write that in now, equals that. Okay, now we haven't finished because what we have to do now is find this plus c. Okay, we don't know what this plus c is. So how are we going to find it? Well, we've got the fact that it passes through the point 1, 2. So now what we do is we substitute 1, 2. Oh, not 1, 2, sorry. Substitute x equals 1 and y equals 2. That will enable us to find the c. Okay, so let's do that. So 2, okay, so just so you can see what's going on here a bit more clearly, I've got a bit of a cluttered slide now. Just drew a line down here. Okay, so 2, because that's y or g of x, equals 2 times, replacing x with 1, power of 3 on 2, plus 2 times 1 plus c. 2 equals 1 to the power of anything is 1, so we're going to get 2 here, plus 2 plus c. That means 2 equals 4 plus c, and therefore c equals negative 2. So our value for c is negative 2. So our equation, okay, if I just free up some room here, actually no, I can squeeze it in here I think, down the bottom. So our equation, our g of x is 2x to the power of 3 on 2 plus 2x. And because our value for c was negative 2, we get a minus 2 there. Okay, so that's our equation. Put a yellow box around it there. You can quite clearly see it there. So let's just go back. We had our derivative, okay, our g dash of x. We had to find our original equation. How do you get the original equation from a derivative? You integrate. So I've integrated there. I've integrated by splitting them up into two separate integrals. Okay. And then I've integrated both. A little bit tricky here with the the power of 3 on 2 over 3 on 2 bit, but we dealt with that. Then we've got our plus c. How do we find our plus c? Well, we know we've got a point 1, 2. So if we put, instead of g of x there, okay, instead of g of x there, we put our y coordinate, which is 2. And instead of our x here and here, okay, we put a 1, which is all what I did there. You can see. Then I've got an equation and I can find c. And once I've got my c, it completes the equation like so. If a curve has a stationary point 2, 3 and a gradient 2x minus k, where k is a constant, find the value of k. Okay. What do we know about the gradient at a stationary point? Okay, we know the gradient at the stationary point is 0. So let's start off by equating our gradient, 2x minus k, with 0. Okay, now that doesn't help us find k yet, but we know the x-coordinate of this stationary point. The x-coordinate of the stationary point, ladies and gentlemen, is 2. So I can actually put 2 in there because I know that's the value of x at the stationary point. Minus k equals 0, 4 minus k equals 0, k equals 4. So I found our value for k. Next up, we've got to find the value of y when x equals 1. Okay. Well, to do that, we're going to have to find the original equation. Okay, so it's the same sort of deal as before. We now know our derivative because we found the value of k. We now know that our f dash x, okay, is 2x minus 4 because I now know that k equals 4. There's our k. So what's our original equation? Well, to get f of x, we're going to have to anti-differentiate, or get the integral of 2x minus 4 dx. Okay, the integral of 2x is going to be 2x squared over 2. Remember, increase the index by 1 over the same index, minus 4x plus c. Okay, so that's going to be x squared minus 4x plus c. Now we know the curve passes through the point 2, 3. Okay, so our equation, of course, is f of x equals this. We just worked that out. So if we let y equal 3 from our point and x equals 2, we should be able to find our value for c. And that is, we can get the full equation for f of x. So I've put in my values for y and for x. So 3 equals 4 minus 8 plus c. And that means c equals 7. So my full f of x now equals x squared minus 4x plus 7. So what's the value of y when x equals 1? Okay, so to find that, we find f of 1. So it's 1 squared minus 4 times 1 plus 7. Okay, so that gets my y value. So y equals 1 minus 4 plus 7. And that equals 4. Alright, so these first 3 videos have been an introduction to integration. The rule dealing with 1 over x and 1 over ax plus b. And also this is the general rule for integration. So you should be able to now do exercise 9a, which is quite a big exercise. That's on page 409. So 9a, page 409. There you go.